All right. Okay, let me introduce myself. I'm Mark Gillespie. I'm a 20-year career military officer. Started out being an armor officer and later was a foreign area officer. And then later as a defense contractor, I got inadvertently into the aerial drone business about 4 years ago. So having previously been a history professor, somebody said that I am very good at this because I can drone on with the best of them. Moving right along, okay, we've got kind of two things we're going to talk about today. One is robust and affordable Class 1, which is the smallest of the UAV classes that the U.S. military uses. For those of you more familiar with the Raven-sized UAV, that's more or less what we're talking about. What we've done at Avigators, which, by the way, 6 of our aircraft are currently down on the California-Mexican border being used by a DoD, Department of Homeland Security project that they're mainly chasing drug smugglers today with them. So we do have some past experience with them. Since they bought them about a year and a half ago, we've made some significant improvements. Now, when those were sold, that was under a company called Invos, which came to an end in April, and I have taken my team and we have created this new company called Avigators. All right, well, let's take a look at it. What are we trying to do with this? Mainly, we're trying to get a very low-cost, affordable, and robust type system. As you can see, it's fabricated out of not carbon fiber, but styrofoam. Why styrofoam? Because your operators, whenever they do finally get onto the manual side of it, decide that a tree is a great thing to land it in and break it apart. With foam glue and fixer, you can put that wing back together in 15 seconds and boom, you're back up in the air again. Okay, what else does it do? It's easy to assemble. You can put it together in 4 minutes or less. It's backpack capable, so one person can carry it, one person can fly it. Now, one other interesting feature of this is the FAA in the last month has approved our system for commercial use in the United States. There's less than 100 companies and airframes that have been approved for that. So, and it was a 9-month, very painful experience, but not only for military uses or first responder uses, we can also use this commercially. One of the other key things is at the bottom is the flight time. Most small UAVs with an electric motor will stay up at most 2 hours. Now with some technology that was presented earlier today, with solar panels and coatings on surfaces, that can be extended. We intend to experiment a little bit with that ourselves. So the 4 hours, it says 3+, we have done it 4 hours with about another 1 hour worth of power left in it. So if we could put some solar panels on that, we could probably keep it up at least 10 hours, we're thinking. What are other things that this has? We try to make it Mark Gillespie proof, which basically means anybody can fly this thing. With the autopilot we have on it, everything from pre-flight, where you sit it down, it will basically tell you, is it ready to go? Once you launch it, it immediately runs up to its loitering capacity and pre-programmed what you want it to do, off it goes. If it has any breaks in the system, it'll automatically come back and automatically land. So Mark Gillespie doesn't have to do anything to it to really smash it up. It'll do it perfectly by itself and it'll come back home in good shape. Now here's some of the specs. We've run this thing out to, we say 15 miles, we actually took it out 21 miles. We strapped it to a light sport aircraft, put the transmitter on it, ran it out, and it was still working. Why did we do that? It's because the FAA won't let it out of our visual sight. So we had to do that to test it. But it worked at maximum range, 15 miles plus. Not too bad. And by the way, if anybody does want the spec sheets or whatnot, the slide deck will be available for you afterwards. Now, one of the other key things why this is made Mark Gillespie proof is you'll notice they've used an Xbox controller on this thing now. I'm too old to really know how to use that. But anybody who's younger than me can probably fly circles around me with it. But we had initially one of the old style control boxes. This was a new innovation that we did last summer, so that now almost anybody of the younger generation can make that work. Now the size of the control box, it's about the size of a big lunch box. And no, we don't put a Coke can in with it, you know, as part of the sales, but that's there to give you an idea of what the size really is. On the top, you've got what is the view that the camera sees, and the lower part is actually a Microsoft Surface, which does all the control of the aircraft and also gives you a display of the telemetry. So it's quite compact and convenient for you. Now, everybody wants to see a little video, so this will show you its launch and what it can do. So if we could kick it on there, please, sir. You'll note all you got to do is give it one heave and it will take itself off. Unlike, say, a Raven, it's a little bit nose heavy, and half the time new people will smack it into the ground. It'll go up, enter its loiter radius, and it knows, okay, this is where home is. Then it will automatically go off on its mission. Now in this case, this is a high definition camera, which is actually the least expensive and, shall we say, sophisticated camera. We put it on another of our birds and said, watch the other one 200 feet below. And this is the fidelity that it gives you. Now again, making it Mark Gillespie proof, we're now in automatic landing mode. One of the things is a major difference with this to a Raven. Anybody who's seen a Raven land, it comes in what's called a deep stall. It's about 5 to 10 feet off the ground and then flops to the ground. Once it does that, it's sending parts every which direction. With our system, we decided we needed a smooth landing so that we avoid that. One of the things we also want to do in showing you this is one of the toughest landings, a crosswind landing, 20-knot winds and gusts, and it comes down safely within 20 feet of target. Not too shabby. Okay, we can go to the next slide, please. All righty. What our company will do is we'll provide you the training, the manuals. We have hooked up with C2 Technologies, which is a company in the Washington, D.C. area that specializes in aviation training. They provide the Air Force training for everything from B-52s to A-10s. And they've been in business 25 years, and they are expert at teaching these types of systems. So we thought it was good. We'll make them. We'll teach folks how to fly, let them train it. So we can provide packages with the experts on the training side. Types of cameras, as I mentioned before, you can put a high definition camera, fairly light, and that gave you in the little video sort of the fidelity that you can get with that. We can also put a FLIR infrared thermal camera for you. And on the right-hand side, you can sort of see what the fidelity of those images are. We can also do multispectral cameras for those who need that for various purposes. We were recently asked by the UN to go up and brief them about using multispectral and hyperspectral cameras for finding mass graves in Africa, which they're still very interested in. What are some of the missions? You folks probably are fully aware of the various missions UAVs can be used for: surveys, surveillance, test any kind of sensor, anything that with a payload that you can get on, you can use it for. Border Patrol, firefighting, disaster relief, search and rescue, among others. Now, one of the more interesting things, less so for your Department of Defense, other than nation building, is precision agriculture. Most folks may not realize it, but domestically in the United States, 80% of drone use, unlike what Amazon thinks, it's going to be used for precision agriculture. What you can do is you can fly over, do a multispectral camera survey, stitch it together digitally, and as you can see in the lower left-hand corner, the dark green shows better crops, the lighter shows areas that are stressed. So you can present to your farmer, here are the areas that you need to add either water, fertilizer, here you've got an insect infestation, etc. So whenever you can also fly it over, and come time for harvest, you can tell that farmer, hey, these 30 acres over on this side are going to be ready in 3 days, but the rest of it is going to be another week. So he can precisely target his labor force and materials to get the maximum out of his systems. Now, we've also got a maintenance support plan that we can throw out there, as well as 3 to 5 day training packages. Currently, we do the training in Florida, about 35 minutes from Disney World. So if you want to bring your kids, probably your kids could probably do a better job of flying it than you can if you're my age. But anyway, exactly. Yeah, let them fly it. I like it. Now, the other part of our presentation today is not the small ones, but let's take a look at what can you do with less expensive but larger type aircraft and make them optionally manned. We actually have taken larger aircraft and made them autonomous, low cost, long range, high endurance, and you can put any kind of package on it up to 300 to 500 pounds. Fundamental approach. We take something that's already out there on the market. This particular one is a Zenith 701, a kit-built aircraft in Mexico, Missouri. So it's a U.S.-made item. The frame itself, the kit is about $20,000. So try a drone, add on an engine, you're looking at $60,000 for the actual equipment. Throw on, if you want to use a high-end control system, add another $100,000. Now let's compare that to, say, a Predator in the millions. I think the low-cost approach speaks for itself here. Now, we're able to do and have tried many different kinds. We've done it with light sport, ultralight size. We're next going to try to focus on how to do it with seaplane or amphibious aircraft. And we've also talked about already using the smaller RC airframe. Okay, so we want to show you, so you don't hear me drone on again too much, we've got another quick video showing the larger type aircraft being used in an autonomous mode. Now you see we took this particular light sport, this one was an ultralight, and we had to throw in, as you can see, weights to simulate the weight of the pilot to keep the CG for the aircraft at the same level. But this particular system was done down at the Avon Park bombing range in 2011. So we've had a little more time to get it better since, but you can change your waypoints in flight, make it do whatever you want on the fly, no pun intended, and it can also do autonomous landings. Again, eliminate Mark Gillespie from the equation. Now, what we are very interested in doing is putting the same type system in this Zenith 701 system. We have right now 2 of these in Avigators' possession, and these things can take off and land. I mean, the best we did was 56 feet, which is pretty darn good. So if you can think of areas where you only have half a football field, that's a great thing to have in your hip pocket. Now you can, if you would kill the video at this point, that would be great, because that's going back into the assembly and disassembly of the small UAV, which you don't really need to see. It's 4 minutes. You don't need it. Type things that the Zenith system, which we call the Black Knight, can do. It should be able, when properly outfitted with bladders for fuel, where the pilots would normally be, it could stay up 18 hours in the air. Concept being, you want to have 24-hour surveillance, have 2 systems. When one's getting ready to run out of fuel, toss another one up, you're good to go. Again, these things are the favorite of missionaries in Africa. It's a tried and true system. Duration and flexibility. You can either fly it with a pilot, or you can throw them out, put in more fuel, and it can stay up longer. Things like Predators, no pilot. It can only be done remotely. These things can carry 300 to 500 pounds on the smaller systems. On the 4-seat version, which we also happen to have one of those, that one can have a payload of up to 1,000 pounds. So you can either get a larger payload, or you can put in more fuel, your choice. Again, the picture up there shows some of the versatility, particularly if you're offshore and you want to send something to the interior of Africa, drop it down on a small piece of flat territory. One of these things is what you want to have. Some of the other missions we have, this is another one of our, this is an amphibious aircraft, a Buccaneer 2B2. We're going to be working on turning that also in an optionally manned system, but they can be used for maritime, port security, chase drug smugglers over the water, you name it. Again, it's versatile. Mission concepts. You have a forward operating base somewhere, Afghanistan, Iraq, or any other new place. One of our Black Knight systems, again, you need 2. You can get 24-hour surveillance over it. This was actually the original concept that we had for developing this. That's actually the original ultralight that we had down at Avon Park. We were able to do that in 6 weeks. So rapid delivery is one of the things we can do. Again, one of the other things I failed to mention is these things have ballistic parachutes. So if anything goes wrong with it, pop the chute, comes down, you'll save 90% of your airframe. Not a bad deal. Any questions? Sir. Hang on.
Fascinating. Recently in Australia, we've had a series of very heavy rain periods and flooding.
Right.
We've had instances where houses have gone down flooded creeks. We've had houses cut off. With your solution, and I'm thinking of the ultralight in this instance, would it be possible to load it up with supplies to go in very low at low speed and automatically drop them out of the bottom of the plane?
Absolutely.
And drop off radio communications equipment?
It can drop off communication equipment. You can use them to provide, wireless service in an area where the towers go down. They're very versatile. Anything you can do with 300 to 500 pounds payload, it'll do it for you.
And you can drop them out the belly or from underneath.
Absolutely.
We also have what's called the Torres Strait up the northern end of Australia, between Australia and Papua New Guinea. In fact, the Australian border is only, in some cases, some of the islands that Australia controls, measured in hundreds of metres from the PNG shore. There's a very large leakage of PNG and Torres Strait Islanders going backwards and forwards. We don't have a problem with that. What we have a problem is other people trying to sneak in with those guys. So you could provide a low-cost solution for our border control people and customs people to monitor that area.
Absolutely. In fact, this is part of what the Department of Defense and Homeland Security are doing with our systems down on the Mexican-California border. I did mention there was mainly looking at the drug smugglers that they're tracking currently. You could do similar things in Australia with this.
Now, going back to the military side of it, what I want to do is put an EW system in there that you fly on a fixed pattern. This is your tiny little one, which is looking for RF emissions from soldier radios, which will not be picked up with normal EW. You've got to send out a sniffer. So if I want to put infrared in there, and what weight can the little one carry?
Well, the little one has got a fairly light payload of about 2 pounds up to 2 kilograms. So that one's a little light. But quite frankly, our engineers, you tell me how many pounds of your system needs to be lifted, we can create something for you.
Right.
That's our forte, is low cost but efficient type drones.
Throwaways, in military terms.
In cost-wise, yes.
Expendable.
Darn near.
Right. Now, it has no radar profile, does it?
Foam doesn't have a lot of radar signature.
And neither does the engine.
It's electric. It's got next to nothing.
Right. Good. Thank you.
So how many are you going to buy? Yeah, we'll see. All right, good. Any other questions? Thank you very much.
Thanks, Mark.